Okay, question 10's on solving trig equations. Big topic, so you're pretty much guaranteed to get a question on this. And you've only got 2 identities to learn this year, so you really must make sure you know both of these. So looking at the starting equation, as soon as I've got something with tan theta and I'm trying to get to a result that doesn't have tan theta, I'm definitely going to want to use this identity. Okay, and you really need to know those identities. No excuse for getting it upside down or anything like that. So 4 cos theta minus 1 equals 2 sine theta, and I'm going to substitute tan theta for sine theta over cos theta. Okay, so then I'm going to think about tidying that up. So 4 cos theta minus 1, so I can say that sine theta times sine theta is sine squared theta. Then that fraction is looking a bit awkward, so I'm going to multiply through by cos theta. Okay, and then I'm going to constantly be reviewing what it is I'm trying to get to, and I'm trying to get to a quadratic that is just in terms of cos squared theta and cos theta. So the other identity that you've learnt this year is that sine squared plus cos squared is 1, so I want to get rid of sine squared, so I can substitute that, scroll down a little bit, I can substitute that for 1 minus cos squared. So 4 cos squared theta, it's a bit of a mess, let's try it again. 4 cos squared theta minus cos theta equals 2, and then I'm going to substitute the sine squared theta for 1 minus cos squared theta, so that's my third method mark for using that identity, and then I'm just going to hope that that all simplifies to what I'm trying to prove. Okay, so that's going to be 2 minus 2 cos squared theta, so if I add the 2 cos squared theta over to the left hand side, and I minus the 2, and I check back up here, yeah, I'm pretty happy with that. I've got the quadratic they were after. Okay, now for part B, well, worst case scenario, even if I hadn't been able to prove that quadratic, I can still use it because I can look at what they've got here, and as soon as the question says hence, yeah, it's going to be involving my previous answer. So if we compare these results, everything is exactly the same, apart from they've switched theta for 3x, which means I can still use this quadratic, but it's just going to be, the angle is going to be 3x rather than theta. Okay, so and I can use that even if something's gone a bit wrong with my proof for part A. I can still look at that and I can still absolutely use that and answer part B. Okay, so let's just check we're okay on that. So we are using that quadratic, so 6 cos squared, and I mean you could do this bit in terms of theta if you wanted and then just change the 3x at the end. That works absolutely fine. So there's cos 3x minus 2 equals 0. So you might want to rewrite that just as a quadratic in terms of a different letter if you prefer. You can put it in your calculator to solve, you can just factorise it, entirely up to you, but it does factorise. What does it factorise to? So it's going to factorise to minus 2 there and plus 1 there. Okay, so y equals 2/3, or and then of course it wasn't y, it was cos of 3x. Okay, so then I'm going to inverse cos each of those. So that's going to give me, let's get these solutions up. So if I inverse cos 2/3, I get 3x equaling 48 point, let's go 19 for now. It's cos, so my second solution is going to be 360 minus that answer. So I think that's going to work out to be too big, but we'll write it down anyway. If I inverse cos minus a half, I'm going to get 120 degrees. And if I do 360 minus 120, I'm going to get 240. And then if I divide each of those by 3, I'll check back to the original. So one thing I could have done actually, if I go back to the original question, yeah, so here where it said go from 0 to 90, I could have changed that in terms of 3x, so multiplied each of the limits by 3, and then that would have told me that I want my values of 3x to go up to 270. So as we thought, that one's actually going to be too big. It doesn't matter if it's there, I can just discount it at the end. So each of those needs to be divided by 3 to get a value of x. Okay, and then for this question, just be so careful. If we go back, just double check the question. It did mention rounding, and they did take your mark off if the 16.1 wasn't to one decimal place, and that'd be a very, very annoying to get that far and lose a mark for that. They would have accepted 40.0 and 80.0 as well for one decimal place, but if it's an integer, you don't have to do that.